Alright, hello and welcome. This is going to be our homework help video for the sequences quiz review. Let's get started with some factorials with problem number 1. It says we need to solve 10 factorial over 8 factorial. So let's simplify that down to a single number. What we don't need to do here is write out the entirety of 10 factorial. We can just start writing out 10 factorial, 10 times 9 times 8. But once we reach this number down here, we can say everything after that could be summarized as 8 factorial. And now the 8 factorial can cancel out, and I'm left with just 10 times 9, 90. Able to do it in my head, don't even need to get out the calculator. All right, very similar thing here. We want to start backing up the bigger number, so 72 is the bigger number. I'm going to rewrite that as 72 times 71 times 70, and it would keep going, but now I've reached 70, so I can just write 70 factorial. And now the 70 factorial can cancel out. And this is over 2 factorial, which is just 2 times 1, which is just 2. And now we got 72 times 71 divided by 2. I do need a calculator for that, but it's quite a bit easier to plug in to get 2,556. All right, we can use this technique to rewrite truncated factorials like this as well. Just look at your biggest number and put it on top, so 15 factorial. But then where do we want to cut this off? Well, after the 11 factorial. So after the 11 factorial is then 10 factorial. So if we write it like this, then everything after that 11 will cancel. Similar thing here. I want to do 44 factorial on the top and then a 40 factorial on the bottom to cancel everything after the 41. But then there's still some numbers in the bottom, 4 times 3 times 2 times 1. All right, that is 4 factorial. And that can be our final answer for that. All right, with problem number 5, we need to simplify, but we just have the algebraic form of this factorial here. So again, we start with the bigger side. The top is a little bit bigger, and we start backing it up. So n plus 1 factorial would be n plus 1 in parentheses times n minus 1 times n minus 2. But we stop after we reach just n, because then we can move the factorial back to there, and now we've got something that can cancel with the bottom, and all we're left with is n plus 1. We can put a box around that. All right, similar thing here. We're going to back up the top here. So n plus 6 factorial is the same as n plus 6 times n plus 5 times n plus 4. But at this point, we move the factorial back to there because now we can cancel what's on the bottom. The n plus 4 factorial. And what's left on top is n plus 6 times n plus 5. We should FOIL that, so this is fully simplified. N squared plus 11n plus 30 after we FOIL that for number 6. All right, number 7. We're going to use that technique to simplify, but then we're going to be able to still solve for n here. So let's back up the bottom. N plus 4 factorial is the same as n plus 4 times n plus 3 factorial. Now the n plus 3 factorial can cancel. I have to leave something behind on the top, so I leave a 1. Now I've got the equation 1 over n plus 4 equals 1 over 8. All right, cross multiply here to keep going. So circle, circle. We get 8 equals n plus 4 minus 4 minus 4, n equals 4. Okay. Determine if the sequence is arithmetic. If it is, find the 52nd term. So if it's arithmetic, there should be a common difference here. What's the difference between these two? That looks like a minus 200. But then this right here, that's also a minus 200. Okay, so this one is arithmetic. Subtracting 200 each time. So can we find the 52nd term? Well, to do that, we have to take the first term, negative 11. Then we want to add to it our common difference of negative 200 times n minus 1. So 52 minus 1. 52 is our n here. So we're adding 51 multiples of negative 200. I'm going to plug this just straight into my calculator. Negative 11 minus 200 times 51. And I get negative 10,211. Okay, good time to maybe double check our answer key. Negative 10,211. Okay. This one, that looks like it's arithmetic. This one looks arithmetic. This one, so it's definitely got a pattern, but it goes plus 6, then minus 6. This is not arithmetic. Not arithmetic. Okay. Has to be the same difference each time. Find the missing term in each arithmetic sequence. All right, so we need to get from negative 15 to negative 35 by adding the same number twice. So I think maybe this one is kind of just obvious that we have to go right in between them with the negative 25 so that we are subtracting 10 each time. But what do we do with something like 15 where we make 1, 2, 3, 4, 5 steps? Well, we can figure out that the difference here from negative 39 to negative 59 is a minus 20. You can do that just by doing negative 59 minus a negative 39 equals a negative 20. And then I divide that into 1, 2, 3, 4, 5 steps. So divide that by 5 and we get that each step is negative 4. Now let's count down by 4s and make sure that we still hit that negative 59. So negative 43, negative 47, negative 51, negative 55, and if I went one more, I would hit negative 59. Okay. Evaluate the series described. So hone in on that word series. That means we are taking a sum here. And it can be helpful if you want to start writing them out. Like this here, number 16 means 22. Well, actually, this one's kind of hard to write out because we don't know what the common difference is. But we'll see. We don't actually need that. Let's just plug this straight into our formula. So what we do is we average the first and the last terms by adding them together and dividing by 2. And then we multiply by the number of terms, which is 12. So average of the first and the last, 22 plus 77 divided by 2. The average is 49.5. And there's 12 numbers, so you multiply it by 12 and you get 594. Okay, and that should work for 17. 18. Here, we don't know what the last term is. So we need to find the last term because that's what goes right here in our formula. But we do know what the difference is. We can see that we're just adding 4 each time. Plus 4, plus 4. So we can use the explicit formula to find the 8th term. To do that, we take our first term, and then we add 4 8 minus 1 times. And so 21 plus 4 times 7 equals 49. So a sub 8 equals 49. Now I know my first and my last term, so I can average them. 21 plus 49 divided by 2. 21 plus 49 divided by 2 is 35. But that's not our final answer. We have to multiply by the number of numbers, which is 8. So 35 times 8 equals 280. So the sum here is 280. Okay, let's do 21. So I've got the first term. I don't have the last term, but we're going to do exactly what we just saw. Use the explicit formula to find that last term. So first term plus the common difference times n minus 1. 26 plus 8 times 12. 26 plus 8 times 12 is 122. So now I've got my first and my last term. I can average them, multiply by the number of terms, which is 13. Equals 962. All right, another good one to double check. So 21,962. Okay. Here it's written still in arithmetic sequence. We can tell that because our variable is just multiplying to its coefficient, no exponents. But it's written in sigma notation. So what we do is we plug in this number to get our first term, and then we plug in this number to that same variable to get our last term. And then this also gives us our n. And once we have the first and the last term in our n, we can find the sum. So 3 times 1 plus 3 equals 6. 3 times 30 plus 3 equals 93. Let's take the average, 6 plus 93 divided by 2, then multiply by the number of numbers, which is 30. So 6 plus 93 divided by 2 times 30, get 1,485. All right, determine the number of terms in each arithmetic series. So we're going backwards now. We've got the first and the last. We've got the sum, but we're missing the number of terms. So we'll just plug things in where they need to go. And then we're going to solve for n here. This can be just plugged into your calculator. 49 plus 99, enter, divide by 2, I get 74. I'm going to subtract that from both sides, so 444 minus 74 is 370, and I'm done. N equals 370. All right, determine if the series or sequence is geometric. So now I'm looking for a common ratio. If it is, find the term named in the problem. So here, are we multiplying by the same number each time? To get from 3 to negative 6, we're going to multiply by negative 2. Does that work again? Times negative 2 times negative 2. Yep, so this is geometric. Now I got to find that 12th term. All right, so our formula for that is you got to take your first term, 3, multiply it by your common ratio, negative 2, raised to the power of how many terms you want minus 1. So 12 minus 1. All right, and this can be just plugged into our calculator. I would turn that into an 11 in your head and then just do 3 times negative 2 to the power of 11, negative 6,144. Let's see if we got it right with 26. Negative 6,144. Okay, is one of these not geometric? Yeah, 29 does not look geometric, because how do I get from negative 2 to 1? I have to multiply by a negative 1/2. But then to get from 1 to 6, I got to multiply by 6, so this one is not geometric. All right, find the missing term in each geometric sequence. So what I'm doing here is I'm going from 3, I'm multiplying by some number r, I'm multiplying by that same number again to get to negative 108. So negative 3 times r squared equals negative 108. Divide both sides by negative 3. I get r squared equals 63, square root. So I found that my common ratio is 6. Now I just got to actually multiply by 6. So negative 3 times 6 is negative 18. Times another 6, let's double check that. Negative 18 times 6 does get me negative 108. What if we skip 2? So negative 3 times something, times that thing again, times that thing a third time equals negative 375. So negative 3 times r cubed, because this is times r times r times r. R cubed equals negative 375. Divide both sides by negative 3. R cubed equals 125. And then raise both sides to the power of 1/3. We'll cancel out that to the power of 3. 125 to the power of 1/3 equals 5. So my common ratio is 5. So negative 13, negative 15. Negative 15 times 5 is negative 75. And then double check. If I multiply that by 5 again, I do get negative 375. All right. Evaluating a geometric series. So we need that formula. This one's maybe worth writing down because it's hard to remember. I'll write it over here. A sub 1 times 1 over r to the n over 1 minus r. All right, so we just need the first term, we need the common ratio, and we need the number of terms. In the first problem, it gives you the n, which is kind of nice. And you can see the first term, so to get the common ratio, you could do the second term divided by the first term, or just see that I'm multiplying by 3 each time. So r equals 3, a sub 1 equals -2, n equals 6. Plug it all in, we're going to get -2 times 1 minus 3 to the power of 6 over 1 minus 3. And just be careful with how you plug this into your calculator. I like to do the 1 minus 3 to the 6th first, press enter, divide that by -2, do that step in my head, press enter, multiply by -2, and I get -728 for 34. Yep. All right, let's see. If they just give you a sub 1, r, and n, it's even easier. You just plug them all straight into the formula. -3 times 1 minus r to the n, 6 to the 7th, all over 1 minus r, 1 minus 6 to the 7th, divided by -5, multiply by -3, we get -167,961 for this one here. Here they give you the first and the last, and then r. So what are we missing? We're missing n, because we've got r, we got a sub 1, we need n. So we've got to work backwards. We know that a sub 1, 4 times our common ratio 5 to the power of n minus 1 equals 62,500. So that's our explicit formula here. Now we can solve for n. Divide by 4, divide by 4. We get 5 to the n minus 1 equals 62,500 divided by 4. 15,625. And now we got to figure out 5 to what power equals 15,625. So because I don't want to add logarithms in here, we're just going to use guess and check. So I'm just going to do like 5 to the 7th power. It's a little bit high, so 5 to the 6th power. And that's exactly on. So I know that this is 5 to the 6th. So n minus 1 has to equal 6. Add 1 to both sides, and I get n equals 7. Now you can double check this. 5 to the 7 minus 1 is 5 to the 6th. Does equal this. Okay, now that I've got n, I've got to plug it into my formula. Do that over here. We need our first term, 4, times 1 minus our common ratio, 5 to the power of n, 7, over 1 minus 5. 5 to the 7th, press enter, divided by -4, times 4, and I got 78,124 for 38. Yep. Okay, what if it gives it to you in series notation? So we need, again, first term, common ratio, and n. So to get the first term, we just have to plug in the 1 here. 5 to the 1 minus 1 is 5 to the 0, so a sub 1 equals 1. 5 to the 0 is equal to 1. Our common ratio is always going to be the base of the exponent, so that's 5. And our n is the number of terms, 9. All right, I'll plug that into our formula over here. 1 times 1 minus 5 to the 9th over 1 minus 5. 1 minus 5 to the 9th divided by -4 and I get 488,281. So, okay, let's just go over that one more time. Plug in whatever number's down here to get your first term. So I plugged in the 1, 5 to the 0th equals 1, so I got my first term. The bottom of the exponent is your r, and this number up here is your n. Now you've got everything for this formula up here. Okay, last couple, determine the number of terms in each geometric series. So we've got the sum. We know that 189 is equal to a sub 1, 3 times 1 minus r to the n. We don't have n, divided by 1 minus r. Now we just got to solve for that n there. We'll start by dividing both sides by 3. I get 189 over 3 is 63. And I'll turn this into 1 minus 2 to the n over negative 1. Multiply both sides by negative 1. Get negative 63 equals 1 minus 2 to the n. Subtract 1 from both sides. Negative 64 equals negative 2 to the n. Divide by negative 1. 64 equals 2 to the n. And now I just got to figure out 2 to what power equals 64. Let me try 2 to the 5th. Too low. Let's try 2 to the 6th. And we get it, so n equals 6. So we can avoid logarithms by just guessing, checking there. And we're done with 42. All right, I'll leave the rest up to you, and have a good rest of your day.